This is SpaceTime Series 23, Episode 96. Coming up on SpaceTime, Hubble maps a giant halo around Andromeda. A new study suggests rogue planets could outnumber stars. And the European Space Agency's Vega launch system returns to flight status. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have mapped an immense halo of gas surrounding our nearest large galactic neighbour, the Andromeda galaxy M31. The findings, reported in the Astrophysical Journal, show that a tenuous, nearly invisible halo of diffuse plasma extends some 1.3 million light-years from the Andromeda galaxy, about halfway towards our own galaxy, the Milky Way, and as far as 2 million light-years in some other directions. This means the Andromeda galaxy's halo is already bumping up against the halo of our own galaxy. The authors also found that the Andromeda halo has a layered structure, with two main nested and distinct shells of gas, one inside the other. They found that the inner shell extends out about 500,000 light-years and is extremely complex and dynamic, while the outer shell is smoother and hotter. The difference between the two is likely the result of the impact of supernova activity in the galaxy's disk more directly affecting the inner halo. In fact, the signature of this activity was the discovery of a large amount of heavy elements in the inner halo. These are cooked up in the interiors of stars and are then ejected into space, sometimes violently, as the star dies in a supernova. And so the halo is then contaminated with this material from stellar explosions. One of the study's authors, Samantha Berrick from Yale University in New Haven, Connecticut, says that understanding the huge halos of gas surrounding galaxies is immensely important because they contain the reservoirs of material that will fuel future star formation within the galaxy. And so by studying these structures, astronomers get important clues about both the past and future evolution of galaxies. The Andromeda galaxy M31 is a majestic grand spiral of perhaps as many as 1 trillion stars. Estimates vary, but some astronomers believe it could be up to twice the size of the Milky Way. And at a distance of 2.5 million light-years, it's so close to us that the galaxy appears as a cigar-shaped smudge of light high in the northern hemisphere autumn skies. And it's getting closer. In fact, Andromeda and the Milky Way are currently hurtling towards each other and are destined to collide in somewhere between 3.7 and 4 billion years from now. That'll destroy the spiral shapes of both galaxies and ultimately creating a new elliptical galaxy out of the wreckage. Berrick and colleagues made their observations using NASA's Hubble Space Telescope, which allowed them to study our nearest big galactic neighbour in unprecedented detail. Through a program called Project Omega, which stands for Absorption Map of Ionized Gas in Andromeda, the authors examined the light from 43 background quasars, the very distant brilliant cores of active galaxies being powered by supermassive black holes and located far beyond Andromeda. These quasars are all scattered behind the halo, thereby allowing scientists to probe multiple regions. Looking through the halo at the quasar's light, the team observed how this light was being absorbed by the Andromeda halo and how that absorption changed in different regions. The immense Andromeda halo is made out of very rarefied and ionized gas that doesn't emit radiation that's easily detectable. Therefore, tracing the absorption of light coming from background sources is the best way to probe this material. So, the authors used the unique capabilities of Hubble's cosmic origin spectrograph to study the ultraviolet light coming from the quasars. The ultraviolet light's absorbed by Earth's atmosphere, which makes it impossible to observe with ground-based telescopes. But they were able to use the cosmic origin spectrograph on Hubble to detect ionized gas from carbon, silicon, and oxygen. An atom becomes ionized when radiation strips one or more electrons from it. An earlier study of Andromeda's halo back in 2015 failed to comprehend just how large, massive, and complex it really was. That's because the previous study used data based on just 6 background quasars within 1 million light-years of the galaxy, resulting in only limited information. Because we live inside the Milky Way, scientists can't easily interpret the signature of our own galactic halo. However, they think the halos of Andromeda and the Milky Way must be fairly similar, since these two galaxies are also believed to be quite similar. Scientists have studied gaseous halos from more distant galaxies, but those galaxies are much smaller in the sky, meaning the number of background quasars bright enough to probe their halos usually only amount to 1 or 2 per galaxy. Spatial information, therefore, is essentially lost. But with its close proximity to Earth, and getting closer every day, the gaseous halo of Andromeda looms large in the sky, allowing for a far more extensive sampling. This is SpaceTime. Still to come, a new study suggests that rogue planets could outnumber stars in the Milky Way galaxy, and the European Space Agency's Vega rocket has returned to flight status. All that and more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, Namecheap.com. As their slogan says, search and buy domains from Namecheap at the lowest prices. Now, this is the service that our team at Bytes.com use to buy and manage our domain names, and we're really happy with the service, support and value we're getting. Buying the right domain name shouldn't be hard, and with Namecheap, we've found it to be anything but that. And you can find your dream domain and join over 2 million happy customers when you register with Namecheap. Trusted with well over 10 million domains, you'll know you're in safe hands when it comes to turning your website idea into reality. And they've got some excellent tools to help you find the right name, like the handy search engine. All you do is type in your desired name, cross your fingers, and press search. And if what you want's already gone, and it does happen sometimes, they'll come up with some great alternative ideas. And if you're looking for some new inspiration, try the new website domain name finder, Beast Mode. It'll help you discover thousands of domain names fast. We've found their prices to be excellent, management tools intuitive, and they're easy to use with excellent custom support if you need it. All in all, it's a great experience all round if you're looking to pick up a domain name or two. So, why not check them out and help support our show at the same time? Just visit spacetimewithstuartgary.com/Namecheap. That's spacetimewithstuartgary.com/Namecheap, and Namecheap is one word. You'll find the URL details in the show notes and on our website. Just visit the support page. That's spacetimewithstuartgary.com/Namecheap. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
An upcoming NASA mission could find that there are more rogue planets, that is, planets floating through interstellar space without orbiting a star, than what there are stars in the Milky Way galaxy. Planets are usually formed around stars in protoplanetary disks. But occasionally, gravitational perturbations will fling an orbiting planet out of its host star system and into interstellar space, where it becomes a rogue planet. In fact, this may have happened in our own solar system. See, it's been hypothesized that as planetary migration moved the gas giants Jupiter and Saturn closer to the Sun and then back out again towards their current orbital positions, gravitational perturbations caused by their outward movement not only forced the ice giants Uranus and Neptune to move further out and swap positions, but in the process, it's thought they may have flung a possible third ice giant either into the far dark outer reaches of the solar system or even beyond our solar system into interstellar space as a rogue planet. Another idea suggests that rogue planets could form independently just as stars form, simply from the collapse of gas and dust swirling together. Now, a new study reported in the Astronomical Journal suggests NASA's soon-to-be-launched Nancy Grace Roman Space Telescope will provide scientists with a window to these strange isolated worlds. The study's lead author, Samson Johnson from Ohio State University, believes Roman could find hundreds of rogue planets in the Milky Way. And identifying those planets will help scientists develop a census of rogue planets, allowing them to infer how many there are in the galaxy. Rogue planets will be identified through a process called gravitational microlensing, using massive foreground objects like stars as gravitational lenses to bend and amplify the light from more distant background objects. First hypothesized thanks to Albert Einstein's 1915 theory of general relativity, gravitational lensing allows a telescope to find planets thousands of light years away from Earth, much further away than other planet detecting techniques. But because microlensing works only when the gravity of a planet or star bends and magnifies the light from another star, the effect from any given planet or star is only visible for a really short period of time, say once every few million years. Making things worse, because rogue planets are situated in space on their own without a nearby star, the telescope needs to be highly sensitive in order to detect that magnification. The Roman Space Telescope's named after Nancy Grace Roman, NASA's first chief astronomer, who was also known as the mother of the Hubble Space Telescope. And that's appropriate because, like Hubble, Roman is based on a National Reconnaissance Office keyhole spy satellite, one of 2 spare Block 3 keyholes the National Reconnaissance Office donated to NASA in 2012, potentially for use as Hubble Space Telescope replacements. The pair were manufactured in the late 1990s and early 2000s and were originally meant to join the constellation of similar keyhole surveillance satellites orbiting the Earth, but were never used because the design was superseded by newer Block 4 and Block 5 versions. Like Hubble, they're built by Lockheed Martin, equipped with a 2.4-metre main mirror and designed to orbit at a similar altitude. But because they look down towards the Earth's surface rather than up into space like Hubble does, keyholes use different optical and ancillary equipment, and they have a shorter focal length, giving them a wider field of view, around 100 times larger than Hubble's Wide-Field Camera 3 instrument. But the donated keyholes weren't complete, lacking among other things detectors, star trackers, prism wheels and filters. The good news is that they did come complete with bodies, mirrors, payload radiators and 1.5-metre long struts at the bottom for spacecraft instruments. As well as hunting for rogue planets, Roman will also search for planets orbiting stars. And the Roman telescope will also test theories and models that predict how rogue planets form. Johnson's study found that this mission is likely to be around 10 times more sensitive to rogue planets than existing efforts, which until now have been based on telescopes tethered to the Earth's surface. It'll focus on planets in the Milky Way between our Sun and the galactic centre, covering an area of around 24,000 light-years. Johnson says while several rogue planets have been discovered already, to actually get the complete picture, the best bet will be something like Roman. Rogue planets have historically been difficult to detect. The study estimates that this mission will be able to identify rogue planets that are at least the mass of Mars or larger. And that's not bad. After all, Mars is the second smallest planet in our solar system, beaten on the itsy-bitsy scale only by Mercury and just a little bit more than half the size of the Earth. Johnson says these rogue planets aren't likely to support life and would probably be extremely cold because they have no star. To find out more, Andrew Dunkley speaking with astronomer Professor Fred Watson.
Fred, let's talk about these free-floating planets, of which there appear to be many, many more than we might have originally considered.
That's correct. So these objects have got many different names, sometimes called rogue planets, sometimes called orphan planets. The name I like best is a slightly strange acronym which stands for Free Floating Planetary Mass Objects. Okay, free floating planetary mass objects, which somehow becomes FFlops, or flops with a double F. And flops is a very appropriate name for them because that's what they are. They're not members of a solar system. They've somehow become disemboweled or disembodied.
They've gone, sod off. We don't want to be a part of your little spin out. We'll do our own thing. Thank you very much.
So these things are not just hypothetical. I mean, we know they exist. They are observed in some of the star-forming regions of our galaxy, most notably in the constellation of Orion, which, if I remember rightly, is where they were first found. And you might wonder how a planet that doesn't have a sun to light it up could shine. How could you detect them? And the answer is that planets of the order of Jupiter's size actually have low-level nuclear processes going on, actually specifically nuclear fission, in their interiors, which generates enough heat that they are detectable in the infrared. In fact, Jupiter, if I remember rightly, emits almost twice the energy it receives from the sun because of these processes going on in its interior. So they do shine dimly in the infrared region of the spectrum, and that's how they have been found. We don't really know where they come from, and the two main theories are, first of all, that they represent a low mass byproduct of the formation of stars. So if you've got a cloud of gas and dust in which stars are forming, you're going to get stars of many different masses forming within that gas cloud, but you'll also get things that form because of gravitational, their self-gravitational attraction that aren't big enough to become proper stars. We already know that there's a class of objects in that category which are very large in number. They're called brown dwarf stars, and they also shine by low-level nuclear processes. They are more than 13 times the mass of Jupiter, so they're quite big. But it's possible that, within that spectrum of masses of objects being formed within a gas cloud, you're going to get things that are planetary mass. And they're just the sort of last remnants, as it were, of star formation. That's one theory. The other theory is that they may well be planets that have indeed formed in a solar system, but because of the gravitational interactions between those planets in that embryonic solar system early in its life, that one of these things has got kicked out. It may even be possible that happened in our own solar system. We might have had an additional planet that got kicked out into a distant orbit. So that's the main thinking of where these things come from.
Could it be both theories, though?
Yeah, it could be both. That's
happen
right.
both ways?
Exactly. You could get you could disentangle. If you have observations of enough of them, you would probably be able to disentangle whether it's one or the other or both of those theories. So that's why the story is in the news, because some work that's been done at Ohio State University has looked at the possibilities for these objects, and they suggest that they may be actually outnumber stars. There might be more of them than there are stars. And that kind of makes sense if they're the sort of leftover debris of star formation, that you might have many, many gazillions of these things forming along with bigger stars which we know about. But the question these authors pose is, how could we find them if they're there, if these objects are so numerous? And they point to an upcoming NASA mission, which is due for launch, not yet. It's, I think, 2025 is when it will be launched. It has the name of the Nancy Grace Roman Space Telescope. Nancy Grace Roman, I think she's one of the brains behind the Hubble Space Telescope. She was a NASA luminary. In fact, she was NASA's first chief astronomer, and also, as I said, known as the mother of the Hubble telescope. So that telescope is a space telescope, and it has the potential to find large numbers of these objects. How can it do that? By the process of gravitational microlensing, which is that phenomenon that any gravitating object, whether it's a planet, a star, a galaxy, or a cluster of galaxies, distorts the space around it. And if you have, for example, a planet passing between ourselves and a distant star, you can see the distant star, but you can't see the planet. But what you can see is the effect of the planet's gravitational field on the light of the distant star. It actually peaks up the light into a signal. The light of the distant star gets brighter as the planet passes in front of it, which is completely counterintuitive. You'd think it would be the other way around, but in fact, the gravitational field of the planet magnifies the light of the star beyond. And it turns out that the Nancy Grace Roman telescope is perfectly suited to observing this kind of phenomenon. We already do see gravitational microlensing of planets. That happens with ground-based telescopes. There's a number of projects that look for that. So it's not a wild guess that this would happen. We see it already. But if you can do it from space, with the kind of accuracy that this telescope will have, you're going to find more. That's the bottom line. And the more we know about these things, the more interesting they will become.
Okay, so they're not part of a solar system. They're not orbiting a star. They've, for some reason, been ejected or formed in a situation where there wasn't an adequate enough star to orbit. So they've floated off somewhere. Are they all sort of within galaxy clusters, or are they or within galaxies, or are they perhaps floating between galaxies?
Good
or a
question.
bit of everything.
So that certainly the ones that have been detected are all within our galaxy, because you need to be able to observe a star beyond them in order to detect them. It's the light of that distant star that you're seeing changing. And so they're all within our galaxy, and in a sense relatively local, because, our galaxy is a very dusty place. So even when we look at the Milky Way, we're only seeing stars 1,000 light years or so away, compared with the 25,000 light years that it is to the center of our galaxy. So they'll be in our galaxy. The ones that have been discovered so far are. I think there are some that have been found away from star-forming regions, but I'm not sure about that. Certainly the ones that were first discovered were within star-forming regions. I guess in an extreme case, you could have one barging into our own solar system from a very distant solar system. It hasn't happened yet, as far as we know.
But the theory is there might be a heck of a lot of them, and they could be all sorts of shapes and sizes too, I imagine.
They will not, however, we believe, account for the dark, the idea of dark matter.
Yeah, someone was going to ask that, and it was going to be me. But yeah, I can imagine. Yeah, they're just again probably just a minuscule part of the entire makeup of the universe.
Yeah, when you look at the amount of mass that they would contribute, even if they are outnumbered stars, the amount of mass they contribute is nowhere near enough to make up the dark matter.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. Still to come, the European Space Agency's Vega rocket returns to flight status with a successful launch. And later in the science report, a new study warns that losing consciousness from alcoholic excess may double your risk of developing dementia. All that and much more still to come on Space Time. The European Space Agency's Vega rocket has returned to flight status with a successful launch from ESA's Kourou Spaceport in French Guyana. The launch, the first since last year's failure, placed 53 small satellites and cubesats into orbit.
Flags are green, weather status is good. We are getting closer to the automated sequence, and I'm keeping my finger crossed.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P80. Allumage P80, décollage.
And there we go. What a sight, Alexandre. You've been working on these Vega launches for years.
Yes.
How does it feel? You're 15.
Very exciting and moving at the same time. It's a Vega rebirth.
Because apart from the first one, you have always been there.
Yes, yes, from the second flight. So you can admire the liftoff on the launch acceleration made on the first stage burn, P80, with an average thrust of 230 tons for a launcher total mass roughly twice less. This is what gives Vega this particular feeling of acceleration.
Very impressive, Beatrice. I mean, you are used to seeing these takeoffs. It's something else, isn't it?
I used to see those takeoffs, but always inside the Jupiter, so never outside. But it's really very impressive to see anyway in the screen.
So, Alexandre, take us through a lot of. We were just listening to the DDO announcing a lot of milestones taking place in very quick succession. Please take us through it.
Yes, now it's the tail off of the first stage is confirmed by the DDO. And now the separation of the first stage is confirmed. So approximately the ignition of the second one, named F23, it is confirmed now.
The information from our launch is being picked up by the first ground station along its path, the station of Galileo in Kourou. In mission control, of course, everyone is following what is happening very, very closely. So everything nominal, as they're telling us in mission control.
The flight was Europe's first designated small spacecraft mission service, designed to provide regular, affordable access to space for small satellites. This is achieved using a new modular lightweight carbon fibre structure called the SSMS dispenser, which can be configured to carry a range of differently sized satellites and cubesats, thereby avoiding the usual constraints of travelling as a secondary payload with much larger satellites. For this mission, Vega carried 7 microsatellites weighing between 15 and 150 kilograms, as well as 46 smaller cubesats. They were released into sun-synchronous orbits between 515 and 530 kilometres in altitude, with the final spacecraft deployed 104 minutes after launch. The return-to-flight status mission had been delayed several times by bad weather. The successful launch follows an extensive Independent Inquiry Commission investigation into the July 10, 2019 failure of Vega flight VV-15. The mission suffered an anomaly 130 seconds into the flight when the forward dome of Vega's Zafiro 23-second stage motor allowed hot gas to enter the stage shortly after ignition, causing the launch vehicle to break apart. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study claims that while COVID-19 patients can suffer long-term heart and lung damage from the infection, many do improve over time. The findings provided to the European Respiratory Society's International Congress is based on new research by Austrian scientists on 86 patients who were evaluated at 6 and 12 weeks after their discharge from hospital. The scan showed that around 9 in 10 patients had lung damage after 6 weeks, but this had dropped to just under 6 in 10 by 12 weeks. Researchers also found that 6 in 10 patients had heart problems after 6 weeks, although this may only be indirectly linked to COVID-19, a sign of the severity of the disease in general. Unfortunately, heart results after 12 weeks weren't presented in the study. The COVID-19 pandemic spread globally from its origins in Wuhan, China. It's now killed more than 900,000 people worldwide and infected more than 28 million others. 2 new studies have concluded that newly discovered deep seabed channels beneath Thwaites Glacier in the West Antarctic may be a pathway for warm ocean water to melt the underside of the ice. A report in the journal Cryosphere found that over the past 30 years, the overall rate of ice loss from Thwaites and neighbouring glaciers has increased more than 5-fold, and ice draining from Thwaites into the Amundsen Sea accounts for about 4% of global sea level rise. Scientists warned that a runaway collapse of the glacier would lead to significant increases in sea levels of around 65 centimetres. A new study warns that losing consciousness as a result of alcohol excess could end up doubling your risk of developing dementia in later life, even if your regular drinking habits are moderate. The findings, reported in the Journal of the American Medical Association, are based on data from 131,415 adults who took part in 7 different studies. Researchers found that among people who had never passed out drunk, heavy drinkers, that is those who had more than 14 drinks per week, were more likely to develop dementia than moderate drinkers. However, they also found that both heavy and moderate drinkers who had passed out drunk were twice as likely as moderate drinkers who had never passed out drunk to develop dementia. Scientists say the future of your wallets, handbags and boots could be mushroom-based. A report in the journal Nature Sustainability says that as opposed to traditional cow leather, fungi can be ethically and environmentally responsibly sourced. Additionally, they can be obtained through upcycling of low-cost agricultural and forestry byproducts, and are carbon neutral in their growth. Researchers say that with a bit of stretching and a chemical bath, shrooms can be made to both visually and physically resemble leather. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from SpaceTimeWithStuartGary.com, or from your favourite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through SpaceTimeWithStuartGary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.